again, that's a cheap Chinese lantern that I wanted to repair, and that's really a project. Can cost, say, an hour, 2 hours for such a simple circuit, but anyway, I have, say, disconnected here the solar panel, here the cheap, completely vague in terms of reception of solar light solar panel. And here the circuit, you can see that I indicated all the wirings here, minus panel, positive battery, minus battery, etc. And I've connected now my power supply with 1.7 volts. That acts as a kind of battery now. So it acts as this battery. It's 1.2 volt. It's nickel manganese hydride, 1.2 volts. So I give the circuit a somewhat too high voltage, but that's no problem. And you can see that the LEDs now flicker, and that has everything to do with the position of this switch. That's here. This switch sets what happens, be it flickering or a constant light. And of course, when you see this and take such a circuit apart, you are absolutely not sure what the function of the switch is, unless, say, you dissect it in a more or less chirurgical way. I didn't do that, but anyway, so what happens when we, surgeon way, I didn't do that, but anyway, here they are flickering now, and when I move the two contact switches here to the other position, I'm gonna do that. My hands are somewhat clean because I've worked in the garden. Not clean, that's what I mean. So in this position, the LEDs, blue LEDs, so they were not, like I told earlier, other color LEDs. They were blue, and with this position of the switch, they are constantly lighting up. So anyway, that gives a kind of solution. I have to solder on the backside of the board these contacts together, and then I hope that I have a first success, namely that I can connect here a new battery of, say, nickel manganese 1.2 volts, and then I'm, say, sure that the LEDs light up, they work properly, and the next project will be to polish here the outside upper layer of resin where all the solar panels are immersed into, to make that the solar light really can enter again through that resin the silicon chips here. And there are 4 of them, I think, but all the chips here give out approximately 0.8 volts. So 4 times 0.8 is approximately 4 volts. That will be the charge current. The charge voltage, by the way, the current depends on the intensity of the solar light, and that will charge that battery. So, kind of mini project that costs a lot of time. It gives, at least for me, a lot of fun. But of course, on the other hand, you can question it. Does it make sense to do all these experiments, etc., to make such a garden lamp working again? Cheap garden lamp, crappy garden lamp, work again.